Morning. Let's get started. One of the things I forgot to say explicitly, maybe I should say that in the first class, was you have your textbook. And if you look at your textbook, for each of the chapter, it covers a lot of topics. And to me, some of the topic is like introduce so complicated feature of the language that you unlikely you will have chance to use those features in your career. So to learn this, as an instructor, this is my primary objectives. Is not have you try to learn every single thing. That's actually possible in this language. Therefore, I don't expect you to read page to page everything in this. And I want you to learn minimum and such that you understand what's the concept of class and object. As example, chapter 11. In order for you to get started, then you can actually, when you encounter those situations, you need to use those language features. You have the capability either use Google or you actually go back to your textbook, try to dig out the detail. As you know, that the language will change, and it will just having more feature. As a programmer, we cannot catch up with that. We just have to grab the most basic concept from this class or from this language. And we have that capability, we can be ourselves extensible in your career later. Okay, so just want to tell you that therefore you won't expect me to cover everything in the chapter, but I will be really happy to answer any question related to this domain. And some of the, to be honest, some of the questions you ask me, I don't even know because I never use it. And if we never use it extensively, we'll just understand the concept, but we cannot know precisely what it is. Okay, just want to communicate that. So in other words, that I really emphasize for you to start writing program. Start to write your own program or using the example from the book, which is really nicely explained. In fact, I feel you are learning enough if you can actually understand 70% of the program that's given by the textbook. I think 70% because some of the other 30%, sometimes they might contain something which is it's unlikely for you to use those features. Okay. All right. Having said that, let's start it with. I tried to use this picture to capture what we have done so far. So my objective at this point is for you to feel comfortable to write one program, describe one class, and create some object, and you can call a member function to that object. So then through that, you understand what is a class, how to write a class, how to create an object, and how to actually be able to interact with the object using your other piece of code. Okay, so right now, the last time we showed the example is you have box.cpp, box.h, which is the class. And then you have another program, which I forgot it is, it's probably ex11_01a.cpp, which that program is include the box.h, and then it actually create an object based on the class box, and then they actually do get boolean from that box. That's how you interact. When you get the more complicated, but this is so basic. If you know how to interact with one class, one object, then there is no reason for you to extend that concept to include billions of objects. If you think about in this room, we have maybe 180 objects. Each of the objects or person object. And within that person object, you have other objects, your mind, your temperature, your health, or your DNA genomics information, or who's your friend is connected to another layer of object outside of this classroom. And think about it, how you will interact in this world could potentially be abstractively captured by a large amount of objects. They just interact with each other. Okay, so the thing is that we know the basic, then gradually through our experience, we will be able to extend to every corner of this world in your whatever objectives you try to accomplish. Okay, so this is what we want to do. First is understand how to define class. Some of you already know that. I just want to recap what we have done. So essentially, when you define a class, or when we say an object being created from this class, it essentially have a two type of entity you need to worry about. So one type of entity is called data or its attribute, and the other entity is what we call the function, and how you will be interacting with that entity. So that's why we have data, we have a method. And in the class definition, this does not one-to-one mapping. To be honest with you, this part, every single object-oriented language they should have. This part is essentially C++ realization of those concepts in arrangement. And very soon you realize they do not match with each other. I will explain to you why. So we learned that, okay, we have already something called public, something called private. Can someone tell me what's the difference between public and private? Yes, please.
For public, some people can access it quickly. For private things, they have to go through more stuff.
Okay, so that's good. So private is that you can only access within the object. You cannot get it from outside, right? That's good. Later, we will add another keyword here. So C++ has three things: private, public, and protected. I haven't started talking about protected because protected is strictly related to inheritance, which is a major subject for object-oriented programming, inheritance, one of the basic principles. Okay. Okay, I want to follow your answer. What's your name?
Nico.
Nico. Okay, thank you. So Nico was saying that you can access something inside or outside between private and. By the way, I'm sorry that I'm very bad in how do I say that, pronouncing people's name. Right? If I pronounce your name incorrectly, sorry about that. If you have a variable inside private area, and you try to access, what I mean you try to access, you remember we have the main function. Inside that main function, I try to access, let me actually show you an example. I like always using example to illustrate the idea. Oh, not this one. I remember I have a bigger one. Ah, this one probably better. Yeah, that reminds me, I haven't uploaded the video for yesterday's, Monday's discussion. I probably need to do that. Book. Wait a minute. So give me a second. This is what I download from GitHub, okay? I mean, GitHub is actually much nicer in my opinion in terms of their interface. Okay, so this is the code we play around the other day. So let me tell you that what is the violation of this rule, public-private. So I go to my the main program, I think is, let me just use 018.cpp. Okay, inside here is our program. But here I actually do something. I do, let me actually bring up the box size. So box size, you see that there is a 3 private attribute is length, width, and height, right? So let's actually try to do something about it. If you see that out, and I said the length of the box object is, and what I did is I directly do this, first box dot. Okay. All right, so I add this line here. You can see that I directly using the object to access its private variable as my syntax. I hope you can see it on the screen. What will happen if I try to compile it? Let me, before I do this, let's say if I want to do compiling this code, minus std is equal to C++ 17. Is that right? Yeah, okay. That sounds okay. If I do separate compilation and 1a.cpp. Okay, if I hit enter here, what do you expect to see? Yes. Right. Okay. So you'll see exactly the arrow. It says so that's why compiler G++ GCC gave you a lot of good information about what mistake we made. So I mean, I don't know about you, but when I was a first-time programmer in college, back then I was overwhelmed by all this error message, tons of message. That kind of made me discouraged, not to want to do programming, because whenever I do, computer always say I did this wrong, this wrong, this wrong. Okay, if you have that mentality like me when I was young, okay, so turn yourself around. As programmer, you welcome those messages. Those are the good advice. They're so nice. It gives you a lot of information to help you to solve this problem, okay? And maybe it's just me, the whole world, just me feel offended when I saw this kind of message. Not just one, okay? It's like I have to flip like 20 pages before I can read through them, okay? So okay, great. It says it's a private member of a box. So it's basically arrow. So this is what we call compiler error. Later we'll see there's different kind of error. One is called compiler error, one is called runtime error. We will see the difference between these two. But this is a compiler error, means the compiler detect you are against the rule of the language. You're trying to do something which is the language is not designed for. So that's why it won't let you continue. Okay, it stopped here. All right, so I want to get your help. I'm a hacker. So hacker means that when I encounter this issue, I have a piece of code I need to present to my client in next 5 minutes. And I don't have time to basically follow the object-oriented principle. I want the code to be runnable. Can some of you suggest to me how do I change the code to make sure this code will run? Yes. Exactly, yes. You can do that, yes. Okay, good. Both valid and good idea. One is a hack, one is more principle, okay? You're doing the hack. We're like socially distant, closer, okay? You're doing the absolutely right thing, academic principle. So let me actually tell you, I can fix this the way Felix fixed it, okay? is I fix it this way. This is typical. Okay, fast software engineering principle. You want this? Fine. I just simply move this line here. Sorry, move it here. Okay, I just make the whole world become an open book. To be honest with you, that's a lot of things I do. Okay, I did, or I'm still doing. This is the quickest way. In fact, in object-oriented programming, with realistics, at the beginning when I do development, I put everything under public because why? I can move very fast. And I'm counting out later in the stage of software development, which you probably will learn from Professor Devin Wu. When you learn the subject like software engineering, then you know there's something called code review. People will review the code and see, hey, what the heck is this? You put everything in public. Okay, guess what? That's typical comment you will receive. Okay. So I'm not telling you should follow this, but I'm just telling you contrast about what you should be doing, what you shouldn't be doing. But let's talk about the correct way. Okay, the correct way is like this. You still have this public, but then I'm actually going to give you another function, double. I said get get length. And I would just say return. Okay, return, but look at this, what I did. I said this length. So this is the right way to do it, all right? Just say, if I want people to access that private, I mean, here is a dilemma about when you design the language, is that, well, why do you actually, if you want to let people access, why do you want to put the function instead of maybe just put this particular things here? I mean, it depends what you want to do, but it's a good coding convention. Try to put all the variable on top, because then it's very clear to know that anything you create this function called getLength, you actually provide information that you intentionally make this available and not because you're doing some hack. You have a question back there, please? Okay, that's a good answer because we only provide a read-only access, right? Okay. But I do want to tell you that I plan to give you an assignment, which is a new assignment. I never assigned this before. In this assignment, you will be receiving a class definition like I provide, which you normally do not have both neither read or write access to that variable. But I want you to write a piece of code to interface with such code, such that at runtime, you will be able to access. So think about it, the compiler don't stop you, but at runtime, you can still bypass. And which means that how do you actually design your program? That's actually differentiate the language like C++ to Java or Python. In C++, you can do that. In Python, it's much harder, to be honest with you. In C is a very powerful language. It allows you to do a lot of things, which is kind of unexpected, and the hacker really like that. Okay, all right. So what do I do if I want allow people to set the variable? If this is just read access, right? What happens if I want to allow people to access, to have a write access? They can modify that. Yes, please. Yes, what would? Okay, good. Okay, so that's great. Great answer. So what I will do is I would just say, probably I would do void. And instead of get, I will say set. And over here, I will say double
new value. And then I would just say this length is equal to new value. Okay, this will allow us to be able to both have a get interface and set interface. So we just basically create explicit. Whenever you access, you have to call this two function, even though we know, well, why can't you just let programmer directly access to that? It's kind of principle. And for me, I really want to bypass very quickly, but as a principle, sometimes you need to do this, okay? So if you look at a lot of public object-oriented library, which people create for you to use, you'll see a lot of set and get interface, which later we'll see some of that. Okay, I'm surprised you didn't ask any question on this page. Yes, why don't you go first? Okay, that's a very good question. You have a question? Same question. Okay. You know, I don't know. I just type and like this. Anybody know why I put this? Have you seen this in Java or other language? Yes. This is basically it's a pointer. So now you see that. Now we go back to the idea of a pointer. This is a unique pointer representing. It's a pointer reference for this object. This object you just create, because if I have a classical box, I can create 5 different boxes, right? And how do you know that which box you're accessing? By the way, these 2 pieces of code are equivalent. I can do this. These 2 pieces of code are equivalent, or I can do just like this. I can do this as well, because the compiler will know in the context of this member function, when you have a length, that length must refer to the one you define in the private area. If the compiler is ambiguous about which length you're talking about, it will flag you with either warning or even error message. But in this context, because the closest variable length in this scope is that double over there. So that's why it's okay for you to, I actually want you to try this as well. I mean, what happens if you actually define another variable under here called length? Can you do that? You define a local variable called length. Try that to see if that will work, okay? I bet compiler will let you do that, but when you do length, it's actually pointing to that local variable length. So essentially, the reason I use this is for readability of the code, mainly for readability. Of course, I use this as a pointer, but as you probably figure out already, I'm the person who really hates pointer, the concept, because it messed up a lot of things. I try to avoid that, but as a C programmer, this is a good feature to use pointer, this notion, because you know whether you're accessing a member variable, the variable in the private section, or it's actually a local variable. You can actually tell the difference. Okay. Okay, any question? All right, let me go back to my slide. Okay, so this is essentially what we have. You have the attribute session, you have the method session. So far, we haven't talked about the third concept called protected, private, public, protected. But now I want you to understand what's private, what's public. I think many of you provide good answer from different angle. It's essentially private is something you can only access with the internal function. whatever function you define, the member function you decide, then you can ask to that. If a public means that any other piece of code outside the box, they can also access directly. Okay, that's the separation. So I want to say a little bit different between, I said there is this is the object-oriented principle that's applied to all languages, trying to support the old concept. And this is a C++ implementation. The reason there is a difference is that I could potentially define the attribute, like the variable length. I can actually declare it whether it is a private or public, as I showed you earlier. I can actually put that line out there. So essentially, the difference between private public is no longer exactly in sync with the separation of data and method. In other words, in C++, you can actually put some function to private. So you can actually have a private function, member function, which only allow from within to actually connect. So I just want to tell you that's the language allow you to do. But as we define those functions called getLength, setLength, those kind of functions, we kind of enforce our usage of C++ language more aligned with the object-oriented principle. So we always only put the variable, the attribute in that private area, and then we only put those member function only in the public area, because you pretty much can do everything you need to do in order to just conform this principle here. Okay. Okay, so I want to show you one thing. We talk about the concept of bracket initialization. That this is something which I feel you need to know about the language this way. So let me show you this one. Okay, so can you see the screen? Oh, I'm sorry, I should probably turn off the light a little bit. Okay, sorry about that. So this is probably easier for you to see the code difference. Okay, the top is a different version of the code, which in fact this is a code I was reading in the 80s and 90s when I first using C++, and this is actually what they did. The new what they call bracket initialization. I mean, the difference is line number 8 and line number 9. I just want you to spend just a few seconds to know they're doing exactly the same thing. It's just a different way of expressing the same stuff. Okay. Okay, my question to you: which way you prefer? I don't want to say which way is better, but I want to say which way you prefer. Yeah.
I was taught the bottom.
You're taught the bottom way, right? So that's actually you're being taught for a newer version about the C++ language. That's good. Yes. Okay, for the Java version, probably, I mean, that's the initial. We treat that as a function call. So that's really the initialization. You have something to say? No, there's no functional difference. It's just the compiler. Compiler is so it's actually hard to decide, which way you want to use. But the important thing in programming is, remember, sometimes we want to write programming, but gradually you realize to read other people's program, your reading capability is probably more important to understand other people's code. Therefore, unfortunately, you have to learn the language when it's getting popular. A lot of people are using this convention this day. therefore, you need to understand both. That's why I said you understand, you gradually learn well, there's new thing. Why is there this new thing? Okay, because there's somebody using it, I need to understand. So I will do that. Okay. So there is nothing about right and wrong, but I do want to say there are different different versions of compiler. If you don't put that dash std is equal to whatever version you try to put in, you're actually getting C++ 98. Just to let you know, you're getting a version of the C++ that was standardized in 1998. And then 0, 3, 11, 14, 17, and then the newest one is C++ 2a. I haven't checked, maybe there is another one after C++ 2a. That's why in our, when I show you the example, I was using C++ 14. And the bracket initialization was introduced at the C++ 11. So it's relatively newer, within about 10 years. I mean, when I say newer, but still within 10 years, that's considered pretty new. That's why you will have that, okay? So you just be aware there's a different version of the compiler. You're going to actually have more, it's really not compiler, it's a language. The industry standardization committee on this programming language, they decide they want to standardize such that all the compiler will support the same concept, okay? All right. Having said that, I'm going to go. You already have it, so I'm going to skip this one. I'll come back this later. Okay, so I want to go back to this picture to kind of capture where we are right now. So this is the real world problem we try to conquer. And object-oriented programming language give us a way to divide and conquer. So you have a huge complicated problem. How do I actually be able to separate the problems such that I can solve the problem nicely in a good way? So that's what we call object-oriented modeling. Object-oriented modeling is trying to identify the entity in this complicated system, and we try to model that as a class. So I can, from that class, I can create objects. So you actually define the class box or class person, which we will see how you can define that later. And what you will do, you see that we essentially what those class and the object we create, they're representing in a digital way of the entity we try to define. And then you use C++, you come out with this definition. And then you create a code, which is, in fact, we have 3 pieces of code, which we will show you. That one piece of code is the box.h, box.cpp, and then we have our main.cpp, which has include this definition. So you have, right, 3 pieces of program. And then what you will do is that we use, say, this example, I'm using 17, C++ 17, but pretty much everything should work, okay? So this part is we use compiler, we define, you compile those 2, and then what you get is you get the DAO file, object file. This is the concept I emphasize called separate compilation. And when you create those, then you're using linker. And this linker will integrate this 2 to be executable. And then that executable, when you execute the program, it will try to either mimicking doing simulation or is actually interact with this real world to accomplish the purpose you try to accomplish. So essentially the whole thing is a object-oriented cycle. from the problem you observe to model those concepts, to really writing the code in C++, to separate compiling, linking from the executable. Of course, I simplify a lot, but that's essentially, oh, one thing I forgot. When you say, remember we have this code first box. So that is basically creating at the runtime when you execute, it will create that object. So that's one is just a specification about the object. The other way is you really create those. Okay. So this picture essentially summarizes what we have done up to this point for this class. Any question before I move on to the next subject? Yes. Where can we what? Oh, the slides. I will right now. The slides are already online, but we can access. But I will send it to. Thank you for reminding me. I will just send it to Canvas, so you can actually get access to that. Yeah, this is something which is I should have fixed. But okay, any question? Yes, please.
So is that like a file? How does that file access?
Oh, the header file. Okay. I skip a step, but let me actually tell you what it is. Inside the compiler, let me actually just insert my new slide. Here's a 3-step. One is called preprocessing. Okay, and then one is called compiling, and then you have linking. Okay, this is a compiler, and I didn't put preprocessing there. So what is preprocessing is doing is try to resolve all the simple, such as include. So this one is actually preprocessing. So when the compiler goes through the preprocessing, it essentially goes to that file, box.h, and bring in all the code into that your program. So your program becomes a lot longer. So let me actually show you. You can actually see preprocessing as well. We have a little bit of time, so I want to just tell you that that's actually an excellent question. I like it because if you understand how this works, and sometimes you cannot duplicate, including multiple files. So okay, where's my code? Not this window. I don't want you. Okay, I want this one. Okay, so this code is we have a piece of code called ecs3b. Let's see how many lines of code this one has. So this one has 12 lines of code. Okay, the first one, WC word count, is the first parameter. Is tell you how many lines of code this file has. So this is a code ex11 whatever 018. So I do G++. If I do -stt, just like what I did before, 17 ex11 a.cpp. This will, oh, sorry, I put -c. This is, oh, I have that issue I haven't fixed. Okay, let me fix it. Let me don't embarrass myself this way. Okay, let me get rid of this. Okay, if I do this, I actually create a .o file. This is called compiling. But if I do this by putting -e flag, capital E, if I do -capital E, the compiler will actually stop after the processing. So I can see what it is. So let's actually try this. If I do this, it will actually generate lots of code. But I want to just put that into a dot, I would say, just say preprocess. I forgot there was another entry I can put. So let's actually take a look what this code looks like. This is after the preprocessing. You can see that it started to insert a lot of stuff was not there. The first part, you see that it actually tried to include all the standard STD stuff because I believe somewhere, I think at first line, I actually include the STD. Did I? Yes, this line IO string. When I include this one will actually expand your code. Let's actually take a look how many lines of code from that 11 lines of code. Now I have 44,000 lines of code after preprocessing. So essentially, before I send to compiler, that preprocessing is actually do that. Okay, so let's actually go through this code a little bit. So let me go to box. You see here. So up to this point, it's already 40. If you look at the line number, it's L44719. So this one is already about 44,000 lines of code. It's all related to just IO string. And starting from this line is going to be box.h. So you see what I have. I just basically copy the code inside here. So essentially the preprocessing is just copy the code from that include, or from any pound sign, including those define, if define, those things are being processed before you throw this product to the real compiler. So this is called preprocessing. Okay. Any questions about preprocessing? Yes.
So when I was thinking, so when you do the DAX, the preprocess and compile, but then like they're separate, it's not like they're repeat process.
Okay, so the compiler, if you by default, it will go all the way to the end. You'll need to know that, but you can stop it. So if I do -E, I stop the compiler after it finished preprocessing. If I do -C, lowercase c, it will actually stop after it finished compiling, producing the .o file. Yeah.
So when you use the DAX, what we're doing is we're individually processing and compiling
Yes.
separate components.
Right.
But then when you connect those, it's that preprocessing again.
No, we don't need to preprocess again because when you connect the .o file, because when we link together, we're actually connecting the .o file, the object file, and the compiler knows this is already processed. So we will not try to preprocess it because the .o file, if you actually look at the .o file, it's pretty messy. The compiler will have no way to handle things like this. I'm going to flip the screen. It looks like this. That's the object file. It's a machine code. So .o file looks like this. It's a binary file, and it's a only machine readable. It's not human readable. It's already compiled into things like machine language or assembly language. I think when you take the course, I forgot what's the current number. It used to be called ECS 50. That's actually talked about the assembly programming, which is the programming closest to the hardware, the CPU. And over there, so what we learn, like a C or C++, is what we consider a high-level language. High-level language is human readable, and we can develop it. Because you can think about the programmer in probably in the 30 and 40, 1930, 1940, they don't have high-level programming language. They have to deal with the binary. In fact, back then, they actually using this kind of switchboard kind of thing to actually do the program. Yeah. It's amazing that the computer has evolved from doing that, and today, pretty much, I mean, the world is actually going this way. I'm not sure how fast this will be, is that you're actually talking to a Google Home. You say, hey, Google, Professor Wu asked me to do homework assignment number 3. Can you actually do it for me? Something like that. All right. It's not today, but eventually the programmer is going to interface with the system very differently. And the system is trying to find out what's your intention and try to pull out all the right piece of code and put together. Voila, you have an application. The only advantage about C, particularly I want to actually give C credit, the C is powerful language, means that it can make things really fast. So today, if I want to write an application, if I don't care about speed, performance, or memory usage, I will probably pick Python. But if I actually care about how do I run this faster, I will use C, because it's a different language. So it's just overhead. You will see that the evolution of computer science will just try to automate this, automate that, and eventually, probably, you don't need to do too many. And eventually, we don't need major computer science. Yes?
So that the compiler check that the syntax is grammatically correct and everything's aligned with the model.
The last part, what can you repeat the last part? Yes, the compiler is going to check the syntax. There are actually 7 phases of compiler. The first phase is a lexical. It's basically just chop your program into small parts. Like this is a keyword, this is a number, this is a string. We try to chop. This is for lexical analysis. And the second step is for syntax analysis. And the last phase of the compiler is called, okay, there is a one phase, maybe phase 5 or phase 6 is code generation. And the last part is called code optimization. So they try to optimize code. So pretty much at the end, when we say code, it's really the binary code that's being produced. So preprocessor is happening before even lexical analysis. It just includes all this. Good question. Okay, any other question? Okay. Okay, so I think we have, no, I want to go here. Okay, just tell you that pretty much this is what we have done so far for this quarter, and hopefully it's not a lot. I didn't tell you a lot about all the features that I potentially can do in the language defined. The only things I will cover from now on for this chapter is chapter 11 is constructor. The different type of constructor that you need to have. But I think I only got 3 minutes here. Maybe I will leave it as a separate topic for Friday. Okay. All right. Good. Just remind you, tomorrow is my office hour, and please, yeah, come visit me from 2 to 5.